How you doing? I'm Michael Stack. I was the release manager on 2.0, so I'd like to tell you a bit about that experience, and probably more importantly, what actually made it into H2 into 2.0. I think it's hard to avoid this. The HBase 2.0 took a long time to come. Um, we branched it 4 years ago. And it actually took a whole year just to stabilize the thing. Our first alpha was a year ago. We did 4 alphas, 2 betas, and then we finally released it at the end of April of this year. We went through a bunch of release managers till it ended up at yours truly. But Matteo and Stephen, they helped out in the early days. Oh yeah, so let's not do this again. I think let's not have a branch where we let it go for 4 years without making a release off of it. The weeds start to build up, the whole thing starts to get overgrown, and just generally, as a project, we build up a mountain of tech debt. There's unit tests would be the obvious one. We were checking in code even though unit tests were all red, and things that maybe are a bit more difficult to figure. Things like performance, we had a lot of performance regression build up inside in the 2.0 branch, just because nobody looked at it. We hadn't looked at it. So I came up with a formula, and the formula is sort of you might recognize. It looks like one that you might know already, but it's the amount of effort expended by people addressing the tech debt is equal to the distance from the original commit that brought on the problem. I square it then just to, the further away you are, the more difficult it is to fix. Anyway, this was super scientific. But so we built up a load of tech debt in HBase 2, and then an army actually fixed it. An army went about fixing the unit test. Now this is a picture from a few days ago. This is the HBase 2.0 nightly runs, and the nightly run involves the total unit test suite on top of Hadoop 2, directly followed by the whole unit test being run on top of Hadoop 3. So the fact that it passes is kind of a miracle in itself. But you can see there's quite a few blues up there. Just the odd flaky will show up, but we're stamping those out too. But it took an army. So let's not do this again. How are we going to avoid doing this in Hadoop 3? I think there's ideas that have been floated around the community. Time-based releases, or I don't know. Anyway, let's figure it out as a community. Let me rehearse some of the goals that we had for the 2.0 release. It might be good to go back and look at what we were thinking. I wanted to put up a picture of Ronaldo's goal against Spain on Friday, but I couldn't get one that conveyed the amazing kick that produced the goal. So anyway, we'll make do with this. So I think you probably all remember that for HBase 1, we took on ourselves as a project. We took on semantic versioning, the major minor patch, and the whole idea is that those that use the project they'll have expectations when they see the version numbers, and us as a project, we will adhere. We'll do our best to adhere to what the people expect when they see these version numbers. But semantic versioning is actually kind of narrow, really. It's only about the API, and HBase is this sprawling thing, and it has facets that show up in MapReduce or Spark, and how do you describe those using semantic versioning? So it's complicated. as a project, a bunch of people have done some really great work to kind of, I suppose, to explain, to do semantic versioning on all the facets that HBase exposes. And so we do things like we take on, we'll annotate our classes, whether they're public or private, and we'll do things like we'll make sure that what we do in a release, we talk about, we explain what people can expect from a particular release, whether it's a patch or a minor or a major. We explain up in our ref guide. So we have this pretty involved table, but you can read it and people have done the work, so you can sort of believe it. So HBase 2.0, we double down on semantic versioning. There's still gray areas though when it comes to compatibility when you're doing your upgrades. Co-processors is an obvious case. Others, metrics, or what happens? How do you move a metric from a particular naming, or how do you remove them when you go between versions? How do you explain that to your operators? Or things like protobufs that you thought were solid. If you want to do upgrades, how do you bring along people that have done things like describe their coprocessor endpoint service in protobufs, but the protobuf is 2.5, and internally HBase wants to use something more recent. So there's gray areas in compatibility. So what did we end up with in 2.0? We, as I said earlier, we doubled down on semantic versioning. Things like the HBase 1 client, you can do your DML, you can do DML against your HBase 2 cluster. It actually works. Even HBase 1 coprocessor endpoints can fly over the top and come into a HBase 2 cluster, and it works. You can't really administrate a HBase 2 cluster from a HBase 1 client. You can read the DEL state, you can read schemas and the likes using your HBase 1 client, but you cannot change them. Replication between a HBase 1 and a HBase 2 cluster works, and it goes the other way. This stuff has been tested. A bunch of people worked hard on curating all of our APIs so that they, what was public, we made more and more of our APIs. We took in as much as we could and made it private so that we were able to change it freely going forward. So a bunch of curation work was done here, and especially in the admin APIs, we expose things like Guava services, the Guava service interface, and we exposed actual protobufs in our public-facing API, which was a problem if you wanted to do update on your Guava or your protobuf. So that stuff's all been shut down now. We only expose POJOs. And then coprocessors, they got an extensive revamp. I'll talk about that some more in the talk a bit later. We wanted to make it so that you could do a rolling upgrade from a HBase 1 to a HBase 2 cluster without downtime. But unfortunately, that project stalled. If anyone's interested in taking it up, you can come talk afterwards. I think it's possible, but it's a bit of work. So without that, an upgrade from HBase 1 to HBase 2 is a stop, install, restart. And I think the minimum that we tested was a 1.2. So make sure you're on a 1.2 before you can go to 2.0. Yeah, so compatibility, there's still a bunch of work to be done in there. So we have to leave something for 3.0 to do. It's an ongoing effort. Other goals that we had for HBase 2, better scale, more regions, bigger clusters, better performance, whether it's inline read and writes or just getting off the ground faster. and better utilization of I/O. I'll come back to this slide later after I've talked about HBase 2. Maybe we'll do a review. So what's inside HBase 2? Don't worry, it's not real. It's from the Alien movie, the first one. So 4,500 issues, over 4,500 issues. I think Misty mentioned it at the top of the day. And about 3,000 are exclusive to 2.0. So a bunch of change in HBase 2. It's a bit embarrassing, but JDK 8 is the minimum now. It'll only run on JDK 8. And Hadoop 2.7 is the minimum. We'll run on Hadoop 3, but I think maybe the Hadoop project's having a little trouble pushing out a version of Hadoop 3 that they'll stand behind in a production context. But as soon as they figure that out, we should be close behind with a release that we think will work on it. Features, there's a few big ticket features. I'll maybe go into them in a little bit of depth. A criticism I got of the Hadoop 2 release from a product manager kind of person was that there's little that we have that's for the user. It's very different from HBase 1. It all seems to be internal changes, and I think that criticism is a fair one. Most of this stuff is all internal to HBase. So we have a new master core. The master kind of got rewritten. We have a bunch of work that was done making it so you could run reads and writes off heap, and then an interesting in-memory compaction feature. I'll do a bit of detail on it in the next few slides. So we have the new master core. We call it the redo of the assignment manager. The assignment manager is the thing that farms out the regions on the cluster, and if something goes down, takes care of getting the stuff back online again. So in HBase 1, this facility, the assignment was the root of most of our operational woes. Regions stuck in transition is something you've probably all heard of. And so we did a rewrite. We did a rewrite of the master core. And I suppose most of the inputs, the design, I suppose, was informed by things like being able to do many more regions, being able to host many more regions on your HBase cluster, getting them online faster, and being able to go to larger scale. This is important consideration when we went about doing the new assignment manager. And then the old assignment was very complicated and difficult to figure out, and in particular difficult to test. And so another base requirement was that the new assignment manager would be scrutable and just testable. And in the old world, anybody like clients or region servers or masters, they could all update state. And in the new world, we wanted to make it so there was, to simplify things for ourselves, we wanted to have only one agent doing the state modification. And no more intermediate state, no more state distributed, or some in HDFS, some in the meta table, some in Zookeeper, no more of that. The master would be the final arbiter. And if anybody disagrees with the master, they get shot in the head. So the promise is a new degree of resilience when you run on top of the new assignment manager. The new assignment manager was built on top of a purpose state machine that was built to handle entities that are native to HBase, like regions and tables. And things like performance were first-class inputs. Procedure v2, a procedure is something that moves a HBase entity from one state to another, and then also procedures in the procedure v2. Sorry, it's an awkward name, but we used to have a kind of a procedure thing in the old days, and we just started calling this thing procedure v2. We should have come up with something, I know, Harry or something, or Larry, but anyway, procedure v2 is how we describe it, or PV2. A procedure is made up of steps. You move the entity through steps. A procedure can be composed so that you could have one procedure that was made up of other procedures, sub-procedures. And then, each step needs to be idempotent. Every step, when it finishes, its state is persisted in a write-ahead log that's local to the master, who is the agent that's running this whole machinery. And then has primitives like being able to lock the various entities of HBase, the regions, tables, or servers. So out of this, we composed the AMV2. That's the assignment manager. Let me talk a little about the off-heaping work, the off-heaping feature. So the off-heaping feature has been in, I suppose, in HBase 2 branch, the master branch, for a long time, and it's been written. I suppose it's taken a while to get the whole thing together. The read path was done first, and then subsequently followed by the write path. It's kind of complicated changing the basic way you traverse a HBase instance, the way cells go from socket to socket out back into HDFS. It's a bunch of nitty-gritty work. But you get the general idea. The idea is that HBase manages memory itself, but it doesn't manage it in the Java heap. It does the management of memory outside of the JVM. And so the promise is that you can live with smaller JVMs. The amount of heap that you have to give to the JVM, it can be smaller, and so then you avoid things like the common issues like the GC, like if the garbage collector is having trouble figuring out what to do. You've been doing nice reads and writes, all nice and hunky-dory, going very nice. The next thing, a big fat compaction comes in and throws everything out of whack. We manage them. If HBase manages the memory, it knows what to do with the how to keep things running nice and smooth. So we take on memory management ourselves. We do it off heap, and so it gets kind of tricky. There's a lot of nitty-gritty work going on. So the off-heap read path was done first, and then the people at Alibaba backported it onto their version of HBase 1. And you might have seen these slides before. They're up on the Apache blog. And Alibaba, they sell loads of stuff, and their big day is 11/11, Singles Day in China. So they sell 100 times more than we sell here in America, because everything's bigger in China. But anyway, this is a description of their cluster before they deployed the off-heap read path. And the main takeaway is not so much the hits per second, but it's how nice and smooth they are in the bottom graph. In the top graph, they're erratic, and they put that down to GC sort of issues, and so at least the promise of off-heap read path is a nice smoother running cluster, and so hopefully the same is true of off-heap write path. I make this distinction mostly because the off-heap read path has been around for longer and has had lots of exercise, whereas the write path is still sort of in need of experience. Our brothers and sisters at Yahoo Israel, they wrote a nice feature in HBase whereby when you're writing into a HBase cluster, you write into the mem store. The mem store fills, and then it flushes out H files. and the people at Yahoo Research in Israel, they wrote this feature called accordion, whereby rather than flush to the disk, you flush to another area of memory. And so they have a general interface called a segment, and then you have a pipeline which is made up of segments. And so the idea is you flush from the mem store, which is usually the Java concurrent skip list, into maybe another concurrent skip list, and then from there into maybe a more compact representation of data storage. You can make lots of improvements, because once you leave the front of the pipeline, no longer will any of the segments be mutable. None of the you can't write to other than the active head of the pipeline. Those that are behind it in the pipeline, those are all read-only. So you can do things like more compact representations in memory. Then optionally, you can have a compaction process, or just that runs against each of the segments in the pipeline, and it looks for things like cells that are in excess of the version limit, or cells that have been deleted while stuff is in memory. And so you can imagine that if you have a work case where you're doing lots of updates to a single cell, you're overriding the contents of a single cell over and over again, especially if you're doing it in short period of time, being able to eliminate these, the updates that have gone beyond the limits, your version limits, or that have been deleted since. If you could get rid of those before you actually flush them out into H files, you could do lots of savings in I/O, and cut down on write amplification. So it's a nice feature for a particular use case, I think is a fair way to say it. It comes in a few flavors. There's, of course, turned off, no in-memory compaction. Basic, which is just moving thstuff through, making segments until you fill memory, and then flushing. And then enhanced is where you'll be looking at the segments, looking for duplicates or overwrites, and then adaptive is kind of smart because it looks to see if it's worth doing the in-memory compaction or not. So there's a bunch of flavors. There was a nice symbiosis between this work, where they were playing with the mem store and data in memory. Nice symbiosis between this team's work and the work that was done by the Intel fellows who did the off-heap work that I talked about in the previous slides. The in-memory compaction, being able to work against off-heaped M slabs or off-heap portions of a mem store. So the two teams worked together. It was lovely to see. There's like 4,500 fixes in HBase, so I'm afraid this thing's going to be like a bit like a laundry list. So I'll just mention a few more, and then I'll just cut it off, and you can all take a view through the release notes yourself after the talk. Medium object blobs. This is a feature that's been in the HBase master or in the HBase branch 2 for a long time, and it's actually, at least at the place where, I'm getting a phone call. Spam. So this is a feature that's been around for a while too, and where I work, we actually ship it in our. It's been shipping in versions of our software for a while. So it actually has been deployed in production environments, and so we have that experience has been rolled back into what's in HBase 2. And so if you want to write cells that are bigger than normal, bigger than a megabyte, if you do stuff bigger than that, HBase doesn't like big cells, but this feature allows you to get away with stuffing maybe video into a cell or large images. The content gets flushed out and gets put into files that sit beside the H files. They're not the same as H files. And when things like compaction comes to run, these files that contain the images and your video or whatever, or the larger cells, they get they get ignored or are bypassed. So yeah, if you have this kind of a use case, this is you might want to take a look at the mob feature. We have a new we have a new RPC chassis put up on Netty. This one has been road tested too. It came in from the folks at Alibaba, and they've been running at large scale, so we enjoyed the benefit of the work they've done. It particularly shines when you have lots of random read kind of workload. Quota's got some more vocabulary, more things that are controlled by quotas. This is an interesting feature. We have our own DFS client. It's async. It's fail fast. It doesn't do things like the current the default DFS client does, where if you have trouble getting to a data node, it does in the background does pipeline reconstruction, figuring out what data node can take over instead. No, we just throw away the stream and go get a new one. It generally works out faster. It does fan out natively rather than pipelining as the current DFS client does. Interesting. This feature starts to shine when you go to scale, when you have many regions and you're writing to all of them on your node, and the interleaving of edits going into the wall. This is when this feature particularly starts to shine. I think when you have a few regions, or you're just writing to one of them, the old client seems to do better, but this one uses way less resources and is better at the interleave. And also it's under our control, so going forward, hopefully we can make it go faster, make it better. A brand new async client in HBase. I'm not talking about the TSDB async client, async HBase. It's a whole new client that's implements all of the table API and all the admin API too, but gives you async. Gives it to you so you can consume it in an async manner. It's nice. I think the way forward will be us putting our synchronous client on top of this async client, but we need to do some more work with it first, I suppose. It needs more experience in production. And then all of our all of our dependencies, they all got upgraded. We did a few big leaps where we went from like Guava 12 to 22 and Protobuf 2.5 to 3.3, and we took it all internal and shaded it so we can have a new Protobuf or a new Guava when Hadoop maybe is still on 2.5 or older. Miscellaneous other stuff. Region server grouping. This is done by our brothers and sisters over at Yahoo. Yahoo here in down the road or up the road. This feature has been deployed on their cluster for quite a while, and when it came into HBase 2, it came with not only the code but the benefit of their experience running it at scale for a long time, maybe a year or so, and it came in with a bunch of best practices as well. So this stuff has actually been backported to the branch 1 now, so it's also available there. And then from Amazon, they helped us out by making it so you could have the wall in one file system and H files go to another. You can guess what they did with that feature, but this thing has also been, I think, backported to branch one. I don't know. It's there's a long list of stuff. There's great stuff in there. Limit compaction speed. You can get a summary of the call queues that are backed up in your HBase instance to see what why it's struggling. You can set priorities on at the client for your operation. There's a load of stuff. What didn't make it? Unfortunately, we still have to figure out our Spark story. There was a hive activity around C++ client there for a while, but that didn't make it. Backup restore didn't make it. Master is a region server for a long time in branch 2. The master by default was a region server, but we had to undo it because it didn't work properly. And then there was also a bunch of work done on making it so we all did hybrid logical clocks, but that didn't make the cut either. So, little detour, coprocessors, how they changed. They got a pretty radical revamp. We pass interfaces now rather than implementations as we used to in the past. We do that because any small change in some of our fundamental classes, any small change, and we'd break coprocessors in the next release. So this is an effort at trying to insulate coprocessors from the running core. Coprocessors got a nice refactor because we were working on JDK8. We could make use of the default in JDK8 interfaces. So now when you write them, you only have to write the thing that's changed. You don't have to fill out all the boilerplate. Some operations moved their location, like splitting a region is now done by the master. So if you were doing observation on region splits on the region server, it doesn't trigger anymore on the region server. It triggers, you have to put something on the master. I talked already about how we undid protobuf from our APIs. We did similar for coprocessor. We now pass in a POJO rather than give you the raw protobuf, so that then we can internally to HBase core we can change protobuf without breaking the coprocessor. And then a bunch of pruning was done, removing facility in coprocessors that just didn't make any sense, like crazy stuff, like letting a coprocessor write its own H files, stuff that didn't make sense. So we just pruned it back. And I'm done with that detour. So what would it take upgrading to 2.0? There's a very nice chapter in the ref guide up on the Apache HBase website on upgrade, and it goes into, of course, notable changes, but even the notable changes are for the operator. It's the things that the operator would notice. So it's from their perspective. They're trying to make it this awkward job. We're trying to make it easy for the operator. So things like how the defaults have changed between HBase 1 and HBase 2. What configs are now available, or if there was misspelling in metrics or configs, what one's been changed. There's a listing of features that got removed for whatever reason. Distributed log replay or prefix tree encoding. And there's a recipe for how to upgrade your coprocessors, the kind of work you need to do to make them work in a new context. There's a little tool called pre-upgrade that you can run on your cluster, your HBase 1 cluster, to figure out what you need to do to make it suitable for HBase 2 upgrade. It'll emit things like it'll complain if you're using an encoding that's not supported in HBase 2. So run that before you do your upgrade. And then HBaseCon. HBaseCon is different in HBase 2. HBaseCon 1, if you run it in HBase 2, it will maybe dump out a report on what it thinks the current state of things is, but it will not write. It will not make changes in to your running HBase cluster. And do not let a HBase 1 HBaseCon run against a HBase 2 cluster. The worlds are different, and it could do damage. Coming back to this slide, the goals revisited. So scale, I think it's fair to say that we could do more regions now. Should be able to do bigger clusters. Performance, we should be able to get off the ground faster. With the new assignment manager, we should be able to get stuff assigned faster. Better resource utilization. I'm not so sure how well we did there. Maybe we can use more RAM now if you're going off heaping. And we did a bunch of work. Hopefully, it should be more resilient in operation, given all the work done in AMV2. Still to do in HBase 2, I suppose bug fixing. There's still some corner cases in Assignment Manager V2. We need more experience, so it's teething issues, I suppose. But stuff we need to fix. Performance, trying to make performance better. That's an ongoing project. Look forward to time-based releases every 6 weeks or so off the HBase 2 branch. And HBaseCon2, we're trying to start up a separate project that runs apart from HBase itself, so that we can roll in fixes faster than, so you don't have to wait for a HBase release to enjoy them. So look forward to that. And then what about the future? What about what's coming up in the future? We have a new release manager for 2.1 Duo Zhang. There'll be a few features that will come in, like serial replication. It's preserving the order of edits as they cross the replication chasm. We're looking at there's a new memstore implementation. It's coming from the folks at Alibaba. It looks really good. It does things like cut down radically on how much memory the current memstore implementation uses, and should be friendlier memory-wise, less antagonistic to the GC going forward. I described this one strangely. Sensible-looking class path for your client, but when you put HBase, when your application has HBase on its class path, there's lots of jars in there, and so there's a project to shade HBase and make it so that there's a single jar or a few jars that you could put on your class path to get HBase functionality and to immunize you against the pollution on the class path, so that you don't have to suffer if you want to have a different version of Guava or any other kind of library, you'll be able to do so. And then 3.0, what's going to happen there? I don't know. Lots of ideas. Ideas are easy. So baseline finished. HBase 2, it took a while, but we shipped it. Congratulations to you all. Good stuff. Anyway, that's all I have. Thank you.